So in lab, you guys got to palpate the knee and the ankle and do lots of different activities with them. So a lot of this information is probably not going to be new to you, but I'm making it available to you to help you study. So there's some specific terminology to the ankle and the foot with regard to just anatomical terminology and osteokinematics, motion terminology. We talked about that a little bit in chapter 1, but now we're going to review it with regard to the ankle. So the plantar aspect of the foot refers to the sole or the bottom of the foot. That is the only place on our body that refers to, so it's very specific. It's a nice term to use because everybody knows what you're talking about. The dorsal aspect refers to the top or superior portion of the foot. Sometimes you also hear it called the dorsum of the foot, which makes sense. We do use dorsal for other parts of the body. Dorsal is another word for posterior. So you can say the dorsal aspect of the trunk, but specifically the top or superior portion of the foot is referred to as the dorsal aspect. We divide the bones of the foot and the areas of the foot into rear foot, midfoot, and forefoot. Those terms are commonly used in the clinic to indicate specific areas of the feet. Because when we start talking about the mechanics of the foot, you'll see how there can be different mechanics at the rear foot, midfoot, and forefoot. Another term that you often hear in the clinic instead of rear foot is hind foot. I know it sounds a little bit like a dog, like it's their hind foot, but it means that the posterior portion of the foot. So if you hear any sneezing in the background, it's my cat Shadow. I think his allergies are acting up today. He's got spring allergies just like the rest of us. So the ankle and foot, they provide triplanar movement. But unlike, say, the hip joint or the shoulder joint, where that triplanar movement comes in one joint, there's not any one joint in the ankle or foot that moves in all three planes, but the combination of movements in all the joints becomes triplanar movement. So there's a lot of movement in the ankle and foot. And the ankle and foot have to have a lot of movement because the job of the ankle and foot is to absorb shock and to adapt to ground surfaces and provide us with a stable base. So our feet are our base of support most of the time when we're standing on our feet. If we're sitting down, of course not, but they have to provide us with that stable base, so they have to have a lot of movement and a lot of stability in order to be able to absorb the shocks of walking and adapt to the different surfaces that we walk on. So you're going to have a lot more information about gait and the gait cycle in your PTA 113 class next winter. However, we're just going to touch on it a little bit because it's hard to talk about the foot without talking about gait because that's their specialty movement. And so we're just going to briefly describe the gait cycle. So when we talk about the gait cycle, it is events that occur while walking within two successive heel contacts of the same leg. So if you look at the little graphic down here, at 0% it's the heel contact of the right leg, and then we go through the stance phase as we're rolling through that right foot, and then the swing phase until the right heel hits again. So that time between right heel and the next right heel contact is the gait cycle. So each gait cycle is divided into a stance phase and a swing phase. So the stance phase is when the foot is in contact with the ground, and the swing phase is when the foot is not in contact with the ground. It's swinging through the air. So when the right foot is in its stance phase, the left foot is going through its swing phase, and vice versa. So usually when we're talking about heel strike or heel contact or mid swing or whatever we're talking about, there's a reference limb. So in this example in the picture, the right limb is the reference limb and the left is doing the opposite. So about 60% of the gait cycle occurs in the stance phase and about 40% in the swing phase. So the elements of the swing phase, of the stance phase, are heel contact, foot flat, mid stance, heel off, and toe off. So we're contacting with the heel and we're rolling through the foot. The swing phase elements are early swing, mid swing, and late swing, so that's pretty easy. We will, as we talk about gait next year, we will go into much more detail. And there are different types of terminology for this. This is the standard gait terminology. There is another gait terminology that's commonly used in rehabilitation settings. That's the Ranchos Los Amigos gait terminology. In the textbook for your 113 class, you will see a table that compares the two. They're pretty close, but in Ranchos Los Amigos, which is a rehabilitation center down in Southern California, that a lot of research is done there. Heel contact is called initial contact, and foot flat is called weight acceptance. So there's a one-to-one correlation between each phase, but they're just different names for everything. So heel contact, you'll also often in the clinic hear it called heel strike. So that's when the heel touches. And a lot of times when you have people with ankle weakness or gait deviations or things, they don't have a good heel contact. They might land on their flat foot, or their foot might touch the heel and then slap down. So we'll talk about different elements of that when we're talking about functional considerations. So with osteology, you got to hopefully palpate all of these in lab, the ones that can be palpated, and look at the bony models. So hopefully this will be a review for you and it will all make sense. So the medial and lateral malleoli, there are ankle bones. Those are so palpable. Unless your ankle is swollen up the size of a basketball, you should be able to find your malleoli. The medial malleolus is a medial projection from the tibia. The lateral malleolus is the lateral projection from the fibula. So they're good landmarks for things in our body. There are also attachments. They act as attachments and pulleys for a lot of the extrinsic muscles that attach in the lower leg and go down to the foot. And you can often tell the action of a muscle, when we talk about muscles in a little bit, from its relationship to the malleoli. So you can think of a line through the medial and lateral malleolus as the medial lateral axis, and if a muscle runs posterior to the medial lateral axis, it's going to do plantar flexion. It's going to have a line of pull for plantar flexion. If it runs anterior to the medial lateral axis, it's going to have a line of pull for dorsiflexion. So if it goes posterior to the malleoli, plantar flexion. Anterior to the malleoli, dorsiflexion. So it's a line of pull. It's what can you do with that line of pull? So those malleoli also serve as proximal attachments for collateral ligaments of the ankle. So the fibular notch is on the tibia. So it's where the tibia articulates with the fibula. So you have, I sort of think of it as, and when we were talking about the proximal tibia and fibula at the knee, the tibial notch is on the fibula and the fibular notch is on the tibia. So it's like that's the specific place on the tibia where the fibula articulates. So the concave, it's concave on the tibia and it's convex on the fibula. It forms the distal tibiofibular joint. So the distal tibiofibular joint is a firm articulation that allows little widening between the tibia and fibula. It's an amphiarthrosis. That interosseous ligament or interosseous membrane holds the tibia and fibula very tightly together to provide stability in the lower leg. So that tibia, the distal tibiofibular joint, serves as a stable socket that accepts the superior portion of the talus, which forms the talocrural joint, otherwise known as the ankle joint. So as we travel down from the tibia to the talus, there are three sets of bones in the foot. The tarsals, the metatarsals and the phalanges. So the tarsals form the rear foot and midfoot, and the metatarsals and phalanges form the forefoot. So we'll go through each one of them. So the tarsals are the bigger, chunkier ones that are more proximal in the foot. So they include the talus, calcaneus, navicular, and cuboid, and the medial, intermediate, and lateral cuneiforms. The three cuneiforms form the transverse arch of the foot. So the rear foot is the talus and calcaneus. The talus has a dome-shaped superior portion that articulates with the tibia. It's called the trochlea. There are three facets on the plantar or inferior aspect of the talus, which articulate with the calcaneus. And the head is on the distal portion of the talus, and it articulates with the navicular. So, in a practical exam on a bony landmark, if I have if one of the numbers is on the superior dome-shaped portion of the talus, I don't just want you to write talus, I want you to say that is the trochlea of the talus, because it's bony landmarks, not bones. The calcaneus is it's your heel. It's the big bone in your heel. The calcaneal tuberosity is the attachment of the Achilles tendon, and just like we've said with all the other bones, you have a big protuberance on a bone, that's where something big attaches. So that is our Achilles tendon attachment, our gastroc and soleus attached through there. It is the most posterior part of the calcaneus. So if I were to have a number on a calcaneus in a practical exam, you wouldn't just say, oh, that's the calcaneus, you'd say that's the calcaneal tuberosity. There are three facets on the superior aspect that articulate with the three facets on the inferior aspect of the talus. That articulation between the talus and the calcaneus is called the subtalar joint, and we'll talk more about joints in the next section. There is a little bony projection on the medial side of the calcaneus that is called the sustentaculum talus, or sustentaculum tali if you're talking about the two of them in your body. It serves as a shelf to support the talus, and its name kind of sounds like that, right? Sustentaculum, it sustains the talus, it holds it up. It also acts as a pulley for some tendons that go through there. So when we go through these and talk about what can be palpated on a person and what can't, obviously the trochlea of the talus cannot be palpated on a person. The inferior or plantar facets cannot be palpated, and the head of the talus cannot be palpated. Although you can palpate the neck of the talus a little bit, and hopefully you got to do that in lab. Finding subtalar neutral is really important if you're fitting someone for orthotics, and we'll talk about that in the joint section. On the calcaneus, you can palpate the calcaneal tuberosity, even though there is a fair amount of thick tissue there, you can palpate it. You cannot palpate those superior facets, but you absolutely can palpate the sustentaculum talus. And it's on the medial side of the bone. And you can sort of think of it as forming a triangle between the navicular tuberosity, the sustentaculum tali, and the medial malleolus. So hopefully you got to palpate that in lab. I want you to try it on some other people too, because palpation takes practice. You have to grow those eyes in your fingers. You have to learn what things feel like. What does bone feel like versus tendon and muscle? So practice palpating, especially these harder ones like the sustentaculum tali. And of course, if we palpate it on a person, it's fair game for the practical. So the midfoot consists of the other tarsal bones, the navicular, the three cuneiforms, and the cuboid. So navicular, it's based on the Latin word for boat because it's a little boat-shaped bone. So you can think of it, it's like the Navy, navicular, and it's a little boat shape. The cuneiforms are, they're supposed to be triangular. They look a little more blocky than that to me, but there you go. And the cuboid is shaped like a cube. So their names kind of help you out a little bit. So the navicular articulates with the anterior portion of the talus, or the distal portion of the talus. It has a tuberosity on there that is the attachment for the spring ligament and the tibialis posterior muscle. It's called the navicular tuberosity. And again, like we've talked about numerous times now, and we'll continue to talk about, a projection on a bone is there because something attaches to it. So the navicular tuberosity, very palpable on the medial side of the foot. The cuneiforms articulate with the distal end of the navicular. And then the you can talk about them as the medial, intermediate, and lateral cuneiform. You can also say first, second, and third cuneiform. That is absolutely correct. And if you put that on a practical exam, I would mark that correct, because there you are. The first, second, and third cuneiforms, or medial, intermediate, and lateral, articulate with the first, second, and third metatarsals. The cuboid articulates with the fourth and fifth metatarsals, and the distal portion of the calcaneus. So the cuneiforms form the medial half of the transverse arch of the foot, and the cuboid forms the lateral half of the transverse arch of the foot. And we'll talk more about arches soon. So the forefoot is the metatarsals and phalanges. So there are 5 metatarsals. All 5 of them, they're tiny little long bones is what they really are. They have a concave base on the proximal aspect, a shaft, and a convex head on the distal aspect. The phalanges, all 14 of them, they're tiny little shortish long bones as well. They have a concave base on the proximal aspect, a shaft, and a convex head on the distal aspect. The first digit has 2 phalanges, and the other 4 have 3 each, just like in the hand. The metatarsals, the 2, 3, 4, and 5 are fairly slender. The first metatarsal is big because that is one of our major weight-bearing bones in the foot. As we roll through the foot, we bear weight on that first metatarsal, and we push off that great toe. So it's the bone is responding to the forces we put on it. We put a lot of force on it, it's big and fat. The other ones are slender, they don't have as much force on them.